The next problem is to implement a stack in such a way that we should always get a minimum among the stack in order of one time. So for suppose uh, we were given these elements and we need to implement a stack such that we always should get a minimum element. Let's start from here. 2. When you when the stack has an element 2, only element 2, what is the minimum? The minimum is 2. Push that into 2 and then go to the next. When the stack has two elements, 8 and 2, what is the minimum? 2. So the next element we need to retrieve, we need just maintain a variable minimum. In any case, we need to get the minimum. So among the 2 and 8, what is the minimum? 2. So how do you store that element in the stack is the most important thing. This element is greater than the minimum. So 8 minus 2, 6. The such in that way we can get the retrieve these elements after that. Based on this, I'll explain that how it is going to happen in a minute, but for till this part the minimum is still 2. Next, 6. What is the minimum among these three? Still it is 2, and that means the 6 is still greater than the minimum. So just store 4 here. What is the minimum among these 4? Still 2. That means store 23. And next, what is the minimum among these all three? It's still 2. So store 2 here. 4 minus 2, 2. Why I'm storing this is when you popping these elements, for suppose do a pop. You popped it. When you pop it, what you should get? 4. The 4 can be done. 2 plus 2 is 4. We are getting the actual 4. What is the minimum? It's still 2. Even it has 4 elements, it's still 2. Next, 23. Pop another element. You popped it. But what is the pop element? That is the resultant of the pop. It's 23 plus 2, 25. Yes, we are getting 25. What is the minimum still? It's 2. That is true, it's still 2. Then 4. Pop the next element, 4. But when you pop it, you need to add it to the minimum. 4 plus 2, 6. Still it is the popped element, 6. Yes, that is correct. And the still minimum is 2, 2. And we are maintaining the 2 in any case. And we are able to retrieve the actual elements when you do actual pop. So in one process, we are able to maintain the elements, we are able to retrieve the actual elements from the stack, but in reality we are not storing the actual elements in the stack, but we are storing the difference of the minimum and the actual elements in the stack, so that we can always maintain a minimum here and retrieve actual here. And so this retrieving this operation is always a constant one because we are maintaining a minimum there. We will see another example where we can see the clear difference why we are storing these elements in a bit. For suppose we have an array of elements 8, 15, 2, 10, 6 and 18. Now let's apply the same principle here. Have a stack, take the first element. When the stack has the first element, is always the minimum is that element. Minimum is 8. Next, 15. Is 15 greater than the minimum? Yes, it is. So 15 minus 8. What is 15 minus 8? 7. We'll store it. The minimum is still 8. Now 2. So you're having an element which is actually less than the minimum till date. So 8 is the minimum till date. What you need to do now? Now replace the minimum here with the 2, but it will be 2 minus 8, that is a minus 6. Now go to the next element. Is 10 greater than 2? Yes, it is greater than 2. So 10 minus 8, 10 minus 2, that's 8. Have 8 here. Still 2 is the minimum. And then 6. Is 6 greater than 2? Yes, it is. So 4 needs to be stored. Is 18 greater than 2? Yes, it is. So it is 16. This is 2. Okay. Let's start popping out. Pop an element from the stack. When you pop, 16 will be popped. But what is the actual result that we need to get? 16 plus 2, 18. Yes, we are getting 18. So we popped 18. So these are all the elements. So the minimum is still 2. Yes, the minimum is still 2 here. And then again one more pop. So you pop it. 4 plus 2, 6. We got 6s. We popped. And now what is the minimum still? It's 2. Yes, it is still 2 here. And then now 8. Pop one more time. 8 plus 2, 10. Yes, we got 10. We popped. And then next we came here. Pop. Now the actual one. When you are popping here, you're having a negative value. Negative value. You entered the negative value into the stack. That means the minimum value has been changed here. What is the minimum value that has been changed? Whatever the value in the array, that has been replaced by the previous minimum value, and we are storing the difference here. So when actually we find an element which is less than the 0, the element that needs to be popped out is the minimum. In this case, the minimum needs to be rolled back to the previous one. So in this case, when we pop an element, the popped element should be a minimum, that is 2. Yes, that is 2. We popped. Now one more operation that we need to do is we need to bring the minimum element to its previous one. What will be that? The minimum minus the element. So that would be minus 6. 2 minus of minus 6 would be 8. So replace it with the 8. Done. Okay. Now we are rolled back. So when we popped all these elements, only these two elements are left. So when only these two elements are left in the stack, what is the minimum? 8. Yes, we are still maintaining the minimum here, 8. Now pop 15. Pop 7. Is 7 less than 8? Yes, it is. So now it will be 7 plus 8, that is 15. We got a 15 here. And then 8. 8 is the last element. This is the 8. 8. We pop 8. 8 will begin, and the minimum is 8. So this is how we are maintaining the value of minimum at any point of time by storing the differences of the minimum and the value of the array in the stack. We will code this out now. Let's start the code. What is that? Get minimum. Get minimum of an array. So suppose we are giving an array and size n, that's fine, but we need to implement a stack in such a way that let's have a stack that is public stack as new stack. You have a stack now. Once you have a stack, you keep pushing. Initially you need to push the first element, so the initial one is s dot push of a of 0. That is for sure. So this is the stack we have pushed. For suppose the stream, I forgot what that is, maybe 6, let's say 6. So 6 to 10 1 18, maybe let's suppose this 6 we pushed, done. Now what is the minimum? The minimum initial minimum would always be a of 0. That is also there. So minimum we are maintaining here as 6. Maintaining as 6. Even if you pop, you need to get this minimum. We're implementing, we're building a stack here. We're building a stack here. So I start push. Now another one. So for int I equal to 1, I less than, and I plus plus, we are pushing it. When you push into an array, the initial thing is if a of I is greater than or equal to min, you just push a of I minus min. You're just pushing it. That's it. Else, that is not the case, what you need to do? You need to actually, no matter what, we need to push this into the stack, but if this is less than the minimum, then oh yeah, if this is less than the minimum, then the minimum would become a of I. But before that, what we need to do, irrespective of the comparison, we just have to push it into the stack. So you just push it. In any way, you need to have an element in the stack. So s dot push a of I minus minimum, that is for sure. If at all a of I is less than the minimum, that is one more operation that we need to do, is minimum needs to be replaced by of. Yes, this is the one. We're done. This is a return minimum. Return min. Okay. We have implemented the stack now. It's not a return thing. It's a void. We just implemented the stack. It doesn't return anything. We implemented the stack. We have a stack now, complete stack. SC is the stack. Now the operation on the stack should give us the minimum. The min should be a global variable, so that the min always will have been updated, and this can be accessed anywhere in the class. And s is also a global, so it should not be inside that. So one more change to this code would be this will be outside of the function. This should be a global, and min also should be a global one. Once we implement the stack, whatever the operation is performing on the S, based on that the minimum will be changed. This is the implement stack void form stack, whatever it may be. The stack is now completed with. So the stack will have a 6, so min will have a 6, and then 2, 2 minus 6 minus 4, minimum will have 2, 10 minus 2 8, minimum is still 2, 1 minus 2 1, minus 1, and then 18, 18 minus 1 17. This is the stack that we built here. Now the operations. Get minimum. So in the main method, for suppose you did a pop operation, so the method pop, so if you want to return anything, that will be a int pop. The pop is not a built-in one, but it is a our own function. What actually this pop do? It just get the int x is equal to s dot peak, but what this what actually it does, it will just check if x is less than the 0, that means negative, then the element that needs to be popped is the minimum. So return minimum, but before that we need to do some operations. What are the operations that we need to do? That means the minimum needs to be updated to the previous one. That means min is equal to min minus x. Done. That is one thing. The minimum is rolled back to the 2 now. And return minimum is equal to, but suppose int y equal to minimum needs to be maintained here. The min equal to min minus x, return y. This is what you need to do if x is less than 0. Else you just return x plus min. That's it. Int pop. This pop is nothing but the popping an element, but minimum is still maintained. Get min always, that is int get min always return the minimum, which is a global variable. When you do the pop operations, that will happen, that will take care of this pop function will take care of the pop operations. The minimum value will keep on updated. At any cost, the minimum value will be maintained, this minimum global variable. At any point of time when you call this get min function, you will get the actual min value based on the number of elements present in that stack. That is it.